Hello students, so in this session we are going to discuss about fundamental concepts and operations of algebra. In previous session we discussed something about this chapter and we are continuing in this session further. And so let me connect you. In last session we discussed about algebraic expressions. So for an example, this 5x square plus 3x minus 2. So obviously you are clear about this. This is an example of algebraic expression. So, and you can also identify the number of terms. So the terms are separated by plus or minus sign. So how many terms are there? This is one term. This is another term. This is another term. How many terms are there? This is 1, this is 2, and this is 3. So there are 3 terms. Now let us analyze each term. We discuss about constants and variables. So constants have fixed value and variables may have different values. So let us pick up this term 5x square. So in this case this 5 is constant and this x square is variable. And I hope you are clear up to this point. Now we are going to continue further and we shall take this term first, that is polynomial. So let us discuss about polynomial. What is a polynomial? So polynomial is an algebraic expression in which all the variables or simply the variables have non-negative integral exponents. So an algebraic expression in which all the variables have non-negative integral exponents. So let us underline these terms: non-negative and then integral exponents. So all the variables, for an example, this 5x to the power 3 plus 2x minus 5. So this is the variable x. The exponent means power of this variable is 3, power of this variable here it is 1, and so the powers means exponents must be non-negative and they must be integral also. So this is non-negative integer. If power is considered as 1, so 1 is also non-negative integer. Let us take some examples where we do not find such conditions, means how to identify whether an algebraic expression is a polynomial or not. So for an example, 5 root x minus 3. So let us see this. This is an algebraic expression. This is variable, this is constant, this is constant. Okay, how many terms are there? There are 2 terms separated by minus sign. What about the variable? Here x is variable. This root x, this means this is 5x to the power 1 by 2 minus 3. So what is exponent? Exponent means power of variable. Here it is 1 by 2. 1 by 2 is not integer. So therefore this is not a variable. Let us take another example. So let us say this is 5 by x square minus 3. So what about this first term, 5 by x square? It can be simplified. You are aware about the exponents, means power. So this is 5. If x square is to be moved here, its power will become negative. So 5x to the power minus 2 minus 3. So the exponent of this variable is minus 2. It is not non-negative. So this does not fulfill the criteria to be a polynomial. So this is also not a polynomial. So I think at this stage you can identify a polynomial, whether a given algebraic expression is a polynomial or not. Now we are coming to different types of polynomial. So polynomial can be classified on the basis of number of terms. This is monomial, binomial, trinomial. So mono means one. So a polynomial having only one term. For an example, let us say this is 5x, another 3x, y, z. So this is a term. This is for this. If a polynomial is having only 5x, means only one term. Another polynomial, this 3x, y, z, this is only one term. So this polynomial will be known as monomial polynomial. Now binomial means two terms. Bi means two. Let us say 5x plus 3. So how many terms are there? Two terms are there, binomial. Nothing great about it. Maybe 3z minus 5. Another binomial. Trinomial, as the name suggests, tri means 3. So 5x square plus 3x minus 2. So how many terms are there? 1, 2 and 3, trinomial. And similarly, more than 3, more than 3, 4, 5, etc. we can classify polynomial based on number of terms. Now we are coming to discuss about this term, degree. So what is degree of a polynomial? So I am writing here this degree of a polynomial. We are discussing these things because we have to consider these aspects while solving different algebraic expressions. So degree of a polynomial. There may be different cases. Polynomial in one variable. So you can identify a variable. A variable is that whose value may change. So I am writing here one polynomial. Let us say this is 5x square minus 2x plus 3. How many terms are there? 1, 2 and 3. What about variables? So here x is the variable. So this can be termed as polynomial in one variable. And as far as the number of terms is concerned, so this is trinomial and trinomial polynomial and polynomial in one variable. So in this case, we have to identify what is degree. So this degree is highest exponent. Exponent means power of the variable. So how many variables are there? Only one variable. This is a polynomial in only one variable. Only x is there. Here it is x into x, x square, here x. So this is a highest exponent, that is power of the variable. Highest power. Here the power is 2. power of x. Here power of x is 1. So what is highest power of the variable x? Obviously it is 2. So here degree is 2. Degree is equal to 2. Let us take another example, or we can discuss another case. This is B. So polynomials in 2 or more variables. So I am writing an example, polynomials in 2 or more variables. Let us say this is 3x square y z plus 5 x z square, and let us take only 2 terms. So this is a polynomial. All the powers of variables are non-negative, and integral powers are there. So this is an algebraic expression. This is a polynomial also, because powers are non-negative integral powers. And as far as the number of terms is concerned, how many terms are there? 2 terms. So because of 2 terms we can call it as a binomial. And now let us identify degree. So in this case, polynomials in 2 or more variables, identify each term. So this first term, see, get the sum of exponents of all the variables. So here the variable is x. This we are going to discuss about degree of each term. So this power of x is 2, power of y is 1, power of z is 1, and this is 2, 1, 3, and 1, 4. So this next term, power of x is 1, power of z is 2, so 1 plus 2, and that is 3. So this polynomial is in 2 or more variables. How many variables are there? X, y, z, x, z. So how to get the degree of this polynomial? See, the sum of all the powers of variables in this term is 4. Here it is 3. We have to pick up the highest sum, maximum sum of powers. So here the degree of this polynomial will be called as 4. Degree is 4. I am taking another example of this kind, and pay your attention over here. This is a polynomial 5x y z square plus 3x square y z minus 4x 3y2 z to the power 4. So how many terms are there? 1, 2, and 3. This is a trinomial, and this is a polynomial because powers are non-negative integral powers, and we have to identify the degree of this polynomial. So this is a polynomial in 2 or more variables. How many variables are there? X, y, z. X, y, z means 3 variables are there. So let us pick each term one by one. We have to find the sum of powers of each term. So sum of powers of each term: x power is 1, y power is 1, z power is 2, and this is 1, 2, and this is 4. So this 4, and what about this term? Power is 2, this is 2, plus power is 1, plus power is 1, and this is again 4. What about this term? Power is 3, and again power is 2, and this z power is 3. So this is 3, 3, and this is 8. So here the sum of powers is 4 in this term. Here the sum of powers in this term is again 4. Here the sum of all the powers of all the variables in this term is 8. So we have to pick up the highest power. So this will be known as degree of this polynomial. So we can write like this: degree is equal to 8. I am taking another example. For an example, now no need to do it so stepwise, just you can count it: 5x y z square minus 3xyz plus 2x square y z square. So let us count it. 2 power is 2, 1, 2, 1, 3 and 1, 4. Keep it in your mind, 4. So 1 power is 1, 2, 1, 1, 2 and 1, 3. So this is 4, this is 3. What about this one? 2 and 2, 4 and 1, 5. So this is the highest sum of powers. So here we can write degree equal to 5. 2, 2, 4 and 1, 5. I hope at this stage you can identify degree of a polynomial. Now based on degree, again we classify polynomial as this way: linear, then quadratic and cubic. And there may be higher degree also. So linear polynomial means degree equal to 1. Here degree equal to 2. Here degree equal to 3. So a polynomial having degree equal to 1 is known as linear. Polynomial having degree equal to 2 is known as quadratic, and this one cubic polynomial. Polynomial having degree equal to 3. Let us have examples also. This 5x plus 3. So what about degree of this polynomial? This is polynomial in one variable, 2 terms, means binomial, and power of x is 1. So here degree is 1. This one 1. What about this 5x square plus 3? And this is degree of this polynomial, and therefore degree is 2 and quadratic, and similarly x cube minus y. So what about this degree? This is 3 and this is cubic polynomial. Up to this point, I think you can identify a polynomial. You can differentiate between algebraic expression and polynomial. You can classify polynomial as monomial, binomial, trinomial. You can again classify and identify linear, quadratic and cubic. And now we are coming to this point, coefficient. Let me correct this spelling. So this is coefficient. Coefficient may be numeric or literal. Let us take an example. This 5x y z square. So this is a term of a polynomial. It has two parts. This is numeric part, and this has this variable part. So this is variable part because all the variables are there. This is numeric part, means constant is there. This numeric part is known as numeric coefficient. And this variable part is known as literal coefficient. This variable part is also known as literal coefficient. So this xyz square is literal coefficient, and this 5 is numeric coefficient. Now we are coming to this term, that is like terms. So I am writing the definition of like terms. Like terms means terms having the same literal coefficients. Literal coefficient. So this is important term, like terms. We have to identify, because in algebraic expressions, while adding and subtracting, we shall say and we shall follow that only like terms are added or subtracted. So how to identify like terms? Terms having the same literal coefficient. For an example, 5x 3yz minus 4x 2yz, this 3zy. See, what about this literal coefficient is x, literal coefficient is x. So these two terms will be known as like terms. What about literal coefficient in these cases? Literal coefficient is yz, this zy or yz both are the same. This order doesn't matter because there is multiplication. So 2 into 3 is equal to 3 into 2. So we can conclude that literal coefficient is the same, and therefore these three terms are like terms. So we can identify like terms, and at this stage we can identify algebraic expressions. I am just giving you a brief idea. Let us recapitulate. We have done algebraic expressions. We can identify variables, we can identify constants, then we can identify whether algebraic expression is a polynomial or not. Then we can classify polynomial based on number of terms like monomial, binomial, trinomial, and further we can classify polynomial based on degree of polynomial. So that may be linear, that may be quadratic, that may be cubic, and that further may be higher degree polynomial. Degree may be 4, degree may be 5, there is no problem. And after that we have identified coefficient. Coefficient may be numeric coefficient, coefficient may be literal coefficient. So literal coefficient is what? That variable part of a particular term is numeric, that is literal coefficient, and constant part or numeric part of that term is known as numeric coefficient. And based on these ideas, we have to identify like terms of a polynomial or algebraic expression. What are the like terms? Those terms having the same literal coefficient. Now we are coming to different operations. Till this stage we have discussed different concepts, we have defined different terms, and we have identified different points and terms, and now we are going to start this part, that is operations of algebra. So these operations may be arithmetic operations, and one by one we shall be taking up these operations. So to add, so how to add two algebraic expressions? So for addition, I am writing the concept here, only those terms can be added which have like terms. So we have to keep it in our mind that only those terms can be added which have like terms. So let us take some examples how to add. So add, I am writing here, question number 1, add 5x square minus 3x plus 4 and 2x minus 3x square and plus 5. Let us say the question reads like this. This is not in order. So we have to identify here, this is 5x square. So this literal coefficient is x square and here literal coefficient is x square. So these terms are like terms, they can be added. Here literal coefficient is x, literal coefficient is x. So these two terms are also like terms and they can be added. And to make it simple, let me keep only positive things, okay, and later on we shall be taking different signs, positive and negative as well. So how to add it? First of all, you write this 5x square and plus 3x plus 4. This order is not the same. Pick up the like term. So like term for this x square, it is 3x square. So take this 3x square and then this is x term. So this is 2x. So plus 2x and this is last term and with constant only, and we have to add. So while adding two algebraic expressions or two polynomials, these numeric coefficients are to be added because here it is addition operation. So 5 added to 3, that is 8, and this literal coefficient is written as it is 8x square. So 5x square plus 3x square is 8x square plus this 3x, again numbers are added. So 3 and 2, that is 5, and x, so it is not repeated x and x, 2x or x is x square, not like that. So it is written only once. So this is 5x. And these are numbers, pure numbers, constants, so 4, 5, 9. So this is how to add two algebraic expressions. And let us take another example, one more example. So add 5z to the power 4 minus 3z, this is yz, and minus 5 this p. So how many variables are there? Z, y, z, p, and take another expression, 3z to the power 4 plus 5yz and minus 2p. So we have to add these two algebraic expressions, and we shall be searching for like terms. So z square is literal coefficient, here z square literal coefficient, yz, these terms are like terms, these terms are also like terms. Now go as per the rule, numbers will be added. Here it is plus 5, this is plus 3, so 5 and 3, that is 8, and literal coefficient is written as it is, that z to the power 4. Now here plus 5 and minus 5, already you have sufficient idea. This is 5 positive and 3, so this sign will be of greater number. So greater is 5, so this is plus, and take the difference of these two. So 5 and 3, the difference is 2, and then the literal coefficient is yz as it is. Here both the terms are negative. So already you are aware that two sum of two negative terms is always negative, so 5 and 2 minus 7, and that is p. So this is how to add two algebraic expressions or two polynomials. And next operation is subtract. So subtract, again we follow the same rule that only like terms are subtracted. So only like terms are subtracted. So we have to take care of that. For example, so question number 3, subtract 5x square minus 3y from this 2x square minus 5y. So this is first polynomial or algebraic expression. This is the second one. We have to subtract this from this. So there are two methods. We can pick up either of the two methods, and I am writing here method 1. So tabular form. So subtract this from this. So first you write this expression 2x square minus 5y. Then you write this one. So 5x square minus 3y. And draw a line. So subtract this from this. So now there is a rule that we have to reverse the sign of all the terms which are going to be subtracted. So take care of this sign. What is the sign over here? This is positive. We have to reverse it. This is minus. This is minus, therefore we have to make it plus. Now we don't have to consider these signs. We shall be taking up these signs for these lower terms. Now we have to follow the rule of addition, just like addition. So this is 2x square and this is minus 5x square. So this sign of greater, that is minus, and that is the difference, and that is 3x square, and this is plus and this is minus, again sign of greater, and this is minus, and difference of 5 and 3, that is 2 and y. So this is tabular form, method 1, how to subtract. We can follow, we can do the same thing. So what is the answer? That is minus 3x square minus 2y. Another way, this is method 2. Method 2. Subtract this from this. Again you write, first of all, this is 2x square minus 5y. And use a bracket. I would like to suggest you for subtraction, put a minus sign and then bracket. This subtract this one, 5x square minus 3y. So now equal to sign 2x square minus 5y. See, you are aware about this. This is minus sign, here it is plus. So plus minus minus and minus minus plus. So this is plus minus minus 5x square. Let us open this bracket, and this is minus minus plus, and this is 3y. And we have simplified it. We have opened the bracket, and then you follow the usual rules of general arithmetic operations. This is 2x square. Let us pick up the like terms. So 2x square, and this is minus 5x square. We have to add these two. Here it is plus, it is minus. So if the signs are different, then we have to write the sign of the greater numeric coefficient. Greater numeric coefficient is 5 compared to 2. It has minus sign, so this is minus. And then we have to take the difference of 5 and 2, that is 3, and put the literal coefficient as it is. Okay, so we have done this and this. Now what about this one? So this is minus 5y and this is 3y. Literal coefficients are the same, therefore these are like terms. And what about the sign? This is positive and this one is negative. Both are different. We have to pick up this sign because this is greater, 5 is greater, and then difference of 5 and 3, that is 2, and write the literal coefficient. And so we are getting the same result from this method also, whichever we shall further continue in next session, and we shall discuss about multiplication and division and some more examples of addition and subtraction. And till then, see you. Thank you.